Hello boys and girls, I'm the Guide Knight and welcome to part 3 of my GD script tutorial. I noticed that last time the video was quite long, so I will try to be a little bit more concise this time, and I'll try to talk about less stuff. Actually, we're gonna talk about functions in this episode. We did mention some of the functions last time, but it was really briefly, and I think that they deserve special attention because they are so very important and there are so many ways you can use them. So basically, let's just go ahead and look at the documentation, right? So here we have the functions part from the documentation, and you see like they always belong to a class. So this is something that's usually very typical to object-oriented languages. You have a class as a sort of a folder for stuff, and you can add variables and functions, also called methods in some other languages, to that class. And then you can invoke or call or execute. They are all synonyms. Basically, you can do all those things with the method or the function inside the class. So in this case, if I have this node, I can add the function ready, right? If you're wondering why it has an underscore, it is because this is a native function to Godot and Godot calls it. We're gonna take a look at those a little bit later on. And this function is called once the node, like the node, this is a class node basically, is added to the scene tree. Like if I add another function, let's say print 5, and this actually prints 5. Right. This is what it does. And if I like call the function print 5 in the ready, and I save, then this will be called once by Godot. This will invoke or call or execute the print 5 function, the method print 5, and then this will call the actually print function, which is basically printing stuff to the console. So if I execute it, I see 5. Amazing function. Yeah, right. So, and this is part of the class. So technically, I could call this as well with self, right? Self print 5. This means that I am in this world GD, and the word GD is of type node. It has this, it extends the node. So this is the class basically, and the class itself is having this method. And this is called like that. This is one of the way of calling the function. We'll talk about other ways a little bit down the road. And then the self variable is always available and is provided as an option for accessing class members, but it's not always required. Yeah, you see that we did call the print5 function with and without self. So it's usually easier to call functions within the same class without self. It's more convenient and less writing. Okay. So basically here is an example. My function, it accepts A and B parameters. Like this is the input of the function. You can have multiple parameters as input. Like in my case, the print5 function, I don't have anything, but I can be, if I rename it to print number and then type in the number, this could be anything. This could be A, B, N or whatever. I'm just gonna type number as the name. This is the name of the parameter, and if I print number, I can basically do the same. Like right now, I'm passing in the number 5 to the print number function. Yeah, and this print number function prints the number for me, right? This is very basic stuff, just explaining to you that you could also have like number 2, and then you can print 1 plus 2, like let's say add 5 and I don't know, 19, and then you have 24, because this is the concatenation for numbers is basically addition, and the concatenations for strings is concatenation. Very fun, right? So basically a function can return at any point. The default value is null. So if I like print the return value of this function, the return value should be null, right? So you see, very interesting thing happens. I call this function, the inner function, the print number. It prints here on line 9, and then it returns null, right? Returns null. It returns null. And it is exactly the same as if I skip line 10, because this is the default return value for all functions. Okay, functions can also have type specification for the arguments and for their return values. Types for arguments can be added in a similar way to variables. So in that case, in my case, I am using integers for both number 1 and number 2, right? They are integers, and the type specification is with a colon, and then you specify the type, or maybe float, or maybe you want to have like a note. This could be note to D or other sorts of input. And in that case, this will say, okay, you have an error because 5 is not of type node to D. You need to create a class of type node to D, and so on. So yeah, let's continue. Okay, and here you have an example with integer and a string. And it is very useful, as I mentioned, I think already, because it prevents bugs and debugging is easier. Okay, so if a function argument has default value, it's possible to infer the type. So in that case, they don't specify the type, but they specify a default value. So if I have another argument, let's say, and add another thing, like I will specify the type for the first two and then infer the type for the number 3, which I'm gonna call number 3, because why not? And it's gonna be 1. I want to have 25. So in that case, I'm calling the print number function only with 2 arguments, but the third one has a default value. So if I actually run it like that, it will I need to add number 3 as well. It will not break, it will compile, but I can also call it with a non-default value, in this case 2. It will override the default value here, and it should be 26 down below. So let me check it. Yeah, 26. But if I did not have this default value, if I try to call the function, it will say too few arguments. Basically, it's giving me a compile error. So it's reminding me that I'm calling a function with less arguments that the function actually has. And the default values are actually very useful, because, for instance, if we change our, let's add a kinematic body here, because I want to show you the and add a script here, whatever. I think we already had some script. Let's just delete everything except one function, and the function is going to be physics process. And this physics process, basically, you can move things by applying a velocity of certain type. And basically, it has the kinematic body to D has this move and slide, move and glide function, for instance, move and slide. And if you hold control down and left click, you can see that it accepts linear velocity. And there are a ton of other arguments that you can pass in, or parameters to this function, but they all have default values. In that case, the vector is of type vector2, and this is of type boolean. It has the false is the default. This is of max slides, is like having a default of 4, and so on. So the default parameters are very useful. Let's go back to our world. Okay, you can also specify the return type. The return type is what your function returns. In our case, it returns null. It's unspecified. But if I return, let's say, a string, hello function or something like that, I can just return it, or I can specify that I am returning this string, right? I can say, okay, before the colon, this is basically where the function begins, you type in the arrow and then your return type, right? So I'm returning string here. And if I try to return something else that's not a string, let's say a number, it will complain. You say, oh, the return type value integer doesn't match the function return type string. So if you see this error message, it means that your return type must be changed to match the return type specified in the function. All right, functions that don't have a return type must return a proper value. Setting the type as void means the function doesn't return anything. Void functions can return early with the return keyword, but they can't return any value. So basically, if I change this to void, what this means is that I cannot return this value. I can return something. And if I now print this, it is still printing null. So this is basically the default, I think, the default value. Like if I didn't have a void here, I could also return. And return basically means that if I have another print statement here, it will not execute. It will actually probably not even compile. No, actually it compiles. In some languages, if you return before your function ends, it gives you a warning. I guess in the Godot it's not like that. So basically you see that I don't see the 1, 2, 3. And if I return after the print 1, 2, 3, it will also invoke that. So it's going line by line, checking if the function returns, and as early as possible, the function can return. So we can also skip ahead a little bit and go ahead to the if else. If else is very useful for doing branching. And I can say, okay, I have like my variable result here. This is gonna be my result. And if the result is greater than 20, I'll return. But if the result is not greater than 20, I'll continue. So I can also write else here and continue, or I can just not write anything, because if I return, basically nothing here is executed. So I can just keep it result is less than 20. Okay, so what happens right now? If I run it, it will go to this line, it will calculate the result of 26, it will go here. This is like the syntax. You type if, like if some statement, then colon, what happens if this statement is true. Then you can also type elif, another statement, statement 2, and then you do whatever you want if the second one is true, and then else at the end if basically all previous statements are false. So I can actually use this directly to show you, like if result is greater than 20, if result is greater than 30, and else. And what do you think will happen now? Let me give you a second. Is great. Is not. Result is basically less or equal to 20. Why? Because if the result is greater than 20, it will go here. If the result is greater than 30, it will go here. Like, why? Or do you think it's gonna go here if the result is greater than 30? That's a trick question. Or a question. Alright, if the result is greater than 30, it will still print here, right? It will not go here, because 30 is greater than 20 and all results will match this one. So let's see what we get. You see result is greater than 20. We can also return the result. And in that case, I'm gonna return integer, because otherwise it will complain. And I can here concatenate with string result is, and then a comma. Basically, it's another function for basically creating a string. It has a return type of string, an input of var args, like variable arguments, and basically it concatenates them in such a way that you get a string in the end. So, and yet another function that we already used quite extensively. So, result is greater than 20, result is 26. So basically if I change that to 20, it will be like result is greater than 20, result is 44. Okay, but what happens if I want to go here, right? I don't want to go in the first one, I want to see especially this one. So I can add a second statement, like this is the first statement. And they are different types of keywords that you can use to concatenate statements. And if I do this right now, it will print result is greater than 20. Like the first keyword is and, the second one is or. I am not sure if you can also use this. Let me see. Okay, obviously you can also use this for, it's like from other programming languages, the and basically sign is meaning an and the two pipes is an or. But you can also use and or. In this case, this will be true. It starts evaluating from the left to the right. And if the first statement is true, if it's an or, it needs only one statement to be true. So if the first statement is true, it will not evaluate the second statement at all. It will just jump here. If the first statement is false, it will evaluate the second statement as well. And then if it's true, it will jump here. And for and, it will evaluate all statements. This needs to be true and this needs to be true. In that case, it will only be here if it is greater than 20 and less or equal than 30. So if I basically do like, I don't know, 15, 14, and 0, it's going to be 29. Then it will say it's greater than 20. If I do like 15 and 4, it will be actually not here because it will be 19, right? Then it will be not here and it will be jumping to the less. So it should be, say, less than 20. It's less or equal to 20. Yeah. All right. So this is how the if and else works. Those are basically the functions. Let's see if there is something interesting as well. There is a nice section here about referencing functions. So functions are very useful, like because you can also call them programmatically on the fly when you do stuff. So if I create an array here, like variable functions, and I'm gonna call my array like multiply and then add and maybe divide, I'm gonna create those three functions. Functions, multiply, it's gonna have like a and b, like two parameters, and I'm gonna basically return a times b. Then I'm going to create a second and a third function. It's gonna be called add and divide, right? And for add, I'm gonna just add them, and for divide, I'm gonna divide them, right? This is simple enough, but it offers you some flexibility. Because I have those functions, I can now call them with this way, basically. It can be called by the function name and the arguments. So my node in that case is self, so I can just call and then the function, right? So if I just do a for loop, like we still haven't really talked about for loops, but we use them anyway. So let's actually remember how for loops are used. I can see here for loop. There is, okay, I am looking for something that will, maybe this looks promising, like if I just type in, right, for v in, or actually value in functions, I can print value. Let's see. I would expect to print multiply, add, and divide, right? Of course, I need to type correctly. So if I run the program now, I would expect to see, yes, multiply, add, and divide. And then I can define like two, like I can define two variables. Var a, it's going to be 10, and var b is going to be 5, right? So this can be anything. Like I just defined two random stuff. And then I can say here, print string. I think actually I don't need the string concatenation function for strings, so I can say like executing the following function, and then I'm gonna add value. So if I run it now, it should still work. Yes, executing the following function, multiply, and then I can say, okay, actually, yeah, I'm gonna need the string because I also want to print the values that I am, like the parameters, like a and b, like width, and then I'm gonna say a, and then comma, and then another comma b. Basically, this should be now fine, except it's not because I missed one bracket. Okay, so it says like executing the following function, multiply with 10 and 5. Like, this is fine. This is what we kind of expect. But we still didn't see the result, right? So let's create a function, a variable called result. And this is gonna be, we're gonna use this paradigm of calling the function, right? My node, call function, name of the function, and arguments. So in this case, I'm gonna use self, call, and then the name of the function is in the value parameter. Like, this is like calling add, right? But in that case, the add is the second parameter of this array. So if I want to like call all the functions, I can just type in the value here, and it will replace it iteratively to multiply, add, and divide. And then I will call the variable, the arguments that I'm passing. Like, basically, I'm passing a and b to the respective function, and I'm gonna print the result. String result is, and then result, right? So let's see what we have. So for multiply, we expect to multiply like 5 and 10 is 50. Yes, nice. For add is 5 and 10 is 15. And for divide is 10 divided by 5 is 2. So this is a nice way of actually calling functions in code, like by the function name. So I can remove the self, I can just use call, and it's going to be exactly the same. And there is also another way to, you can store the function reference. It's basically kind of similar to the other one. I don't know if I prefer it or not. But basically what you do is you create a function reference. By the way, if you select multiple lines and press tab, it will indent multiple lines at the same time. So let me see if I can now store the function, call the same thing with the functional reference. In that case, I will say my node is self, and my function is stored in the value here. And the function reference is now being called with the call function, and my arguments are a and b, right? So if I can move this up before the result, and then I can address, basically make the result equal to the return of this functional reference call, it should have exactly the same response as before. But it's another way of calling the function. Yeah, so you can also have static functions. Static functions basically are useful maybe for libraries, and they cannot access stuff inside the object. So let's say if I would like to have another addition here, like add with special, and then I will add special. Special is basically a variable that I'm gonna create here. It's gonna be 10, nothing super special about it. But basically, if I Control K to comment those, so if I print add with special and say like 1 and 1, I want to add 1 and 1, I would expect basically to have 12, right? So yes, I have 12 because this is basically referencing self.special, right? It has access to the stuff that are inside the node. But if I were to make this static function, this will no longer work, right? This will no longer work because they don't have access to those self parameters and variables. So if I just type in here static and then function add with special, it immediately complains self isn't allowed. And if I remove the self, it will say this is not defined, like can access member variable special from static function. So I need to basically make sure that special is defined, and if I can define it here with constant like special equals 10 or so. Of course that makes no sense. I don't know. Anyhow, maybe constant cannot be part of the... I have a typo as well. Amazing. All right. But yeah, those are static functions. They're especially useful for functional programming because you guarantee that you don't basically you don't abuse it with some hidden state from the methods. Of course, they can still be maybe abused in some way, but who knows. Anyhow, guys, this was it for today. Let's see, maybe the next time we can talk a little bit more about those loops and how they work and matches and whatnot. So I hope you liked it. Yeah, if you did, you can give me a thumbs up. That would help me greatly, and I really appreciate that. Actually, yeah, I don't do that full time, so I like teaching people stuff, and I hope it was helpful for you as well. Very basic stuff, but sometimes basic stuff are what people need. And yeah, so stay awesome, guys, as I know you are. Stay cool, and see you next time. Bye bye.